Welcome back to All This Math. This is Professor Parker. Make sure you subscribe to the All This Math YouTube channel. Make sure you like this video. Make sure you share this video. Drop a comment down below. All right, what are we doing today? Today we are multiplying with decimals. Multiplying with decimals. All right, so this says 48 times 0.2 equals blank. So this is I get these confused, but this I believe is the multiplicand and this is the multiplier. Maybe this is the multiplier, this is the multiplicand. Technically, it doesn't matter because multiplication follows the commutative property, which means that you can switch places, and you'll still get the same product or the same multiple, right? But one of these numbers technically is called a multiplicand. The second number is called the and another number is called the multiplier when you're multiplying two factors. All right, so anyway, 48 times 0.2. Now, as with anything, there's multiple ways to do this problem. So we can use the traditional algorithm for multiplying, and we can set it up like this, stack the numbers on top of each other. We got 48 times 0.2. We don't really need this 0 right here, but I'm going to still just put it there just because. So we got 48 times 0.2. So what we're going to do is we're going to multiply this 2 by each of these digits up here. Each of these digits up here. Then we're going to do the same thing with the 0, multiply that by each of these digits up here, and see what happens. So 2 times 8. We must know our multiplication facts. If you don't know your multiplication facts, that's just nasty work. You got to know your multiplication facts. All right? And it's never too early to learn them, never too early to memorize them. If you're doing work like this, whatever grade you're in, right, you should know your multiplication facts. If you multiply whole numbers by decimals, you should know your multiplication facts. All right, so we got 8 times 2, which is 16. So we're going to write using the traditional algorithm, we're going to do 6 and then carry the 1 up here. Then we're going to do 2 times 4, which is 8, and then add the 1, which gives us 9. All right, so that's 96. But then we got to do 0 times 8, which is 0. Now, we need to indent one space. Indent one space. And we do 0 times 4, which is also 0. And we do like this. Now, why do we indent one space? We indent one space because this digit right here is 10 times bigger than this 2. This digit that's in the ones place is 10 times bigger than what was in the tenths place. The 2 is in the tenths place. So that's why when you multiply, you got to indent one space. What some teachers teach is just to put a 0 right here. That's cool too. Because you want to just indicate that the product of this number and this digit and these two digits is 10 times bigger than the product of this digit and these two digits, right? So 96, and then the product down here on this row is 10 times bigger. Now it's time to add your numbers up. So 6 plus 0 is 6, 9 plus 0 is 9, 0 plus nothing is just 0. Now the thing with the decimal point is when you multiply a decimal, then your product should have just as many digits to the right of the decimal point as the two factors did. I'll say it again. Your final product should have just as many digits to the right of the decimal point as the two factors did. So let's look at 48. 48 don't got no digits to the right of a decimal point. It's got an invisible decimal point right there. So that's 0 digits in 48. But then 0.2 has 1 digit to the right of the decimal point. I should say 1 non-zero digit to the right. Well, no, I wouldn't even say that because it could say 0.201, and then that 0 would count. All right, but if 0 would be at the end of the number, then the zeros don't count. But 0.2 has 1 digit to the right of the decimal point. So that means altogether, out of these two numbers, there is 1 digit to the right of the decimal point, which means in your product, your multiple, your answer, whatever you want to call it, should also have 1 digit to the right of the decimal point. So your answer is not going to be 96. And this 0 don't really matter. When the 0 is in the highest place value, it don't really matter. We can actually get rid of it. You know what I'm saying? We can get rid of that. But our final answer should have 1 digit to the right of the decimal point. Not 2 digits, not 3 digits, just 1. So you should put a decimal point in between the 9 and the 6, yielding you 9.6. So 48 times 0.2 is 9.6. Now, there's some other ways to do this problem that I want to explore right now. I'm just in that type of mood. So what would happen if we I don't know, we thought about this like intuitively. 48 times 0.2. So 0.2 is the same. Let's think about money. All right, so say we got $48. Well, no, not even $48. We just got 48, right? 48 people. Each person gets 20 cents. Each person gets 20 cents. 0.2 is the same thing as 20 cents, right? So What if 48 people got 20 cents? How much money would that be altogether? 48 times 20 cents, right? It's gonna be It's gonna be $9.60 or 9.6, right? 20 cents for 48 people, you know. So that's another way to think of how it would be 9.6. Because you could say what happens is actually you can think of this as like a whole number two. 48 times 2 would be 96. But then you remember that the decimal point was there. So you got to take 1/10 of 96 or divide that 96 by 10, which gives you 9.6. All right, so that's another way to deal with it. All right, now what if I converted this decimal into a fraction? What if I rewrote it like this? 48 times, now this says 2/10. 2/10. That's how you would write it as a fraction. 2 is your numerator, 10 is your denominator. 2 is your numerator, 10 is your denominator. All right, so we got 48 times 2/10. 48, let's treat 48 like a fraction. How do you turn a whole number into a fraction? Put a 1 underneath of it for your denominator. That's how you turn any whole number into a fraction. All right, so now I could cross cancel. I could do that, but I don't really want to do that. Well, you know what? Let's see what happens if we do that, right? Actually, no, I'm not going to do that because that's going to throw everything off because that's actually going to make it more difficult. Not necessarily, but it's going to complicate things. I will say that it will complicate things. Let's do 48 times 2. Let's just multiply horizontal. 48 times 2 is going to be 96. 1 times 10 is going to be 10. So we got 96 over 10. Now, any fraction is just a division problem. That's all a fraction is for real, for real. So 96 divided by 10, anytime you divide by 10, all you're doing is just moving the decimal point one space to the left. That's all you're doing. You're making a number smaller by 1 unit, right, in the base 10 system, right? Or what some curricula teach is to leave the decimal point where it is, instead move the digits. So doing 96 divided by 10, you either, if you're old school like me, move the decimal point one space to the left, or leave it if you're new school, leave the decimal point where it is and move the digits one space to the right. All right, so right now this 96 has an invisible decimal point right there. Right? So you're going to either way use either of those methods. You know what I'm saying? It's a flower, a couple flowers inside of it. I left them up on the board because I thought they was pretty. You know what I'm saying? And plus I miss her. She at a mama house right now. But anyway, 96 divided by 10 is 9.6. All right? So you get 9.6 because we're taking 1/10 of 96. So it's another way to get 9.6. You know what I'm saying? So this fraction can break down. Actually, let's break this fraction down. Like, what if I didn't just do 96 divided by 10 to get this? What if I simplified, divided each number, numerator, denominator by 2? 96 divided by 2 is going to be 48. 10 divided by 2 is going to be 5. Now, how is this equivalent to 9.6? Let's think about this being an improper fraction. Improper fraction, numerator is a bigger number than the denominator is. Improper fraction. And let's say we convert it to a mixed number, right? We got a whole number part and a fraction part. That's why it's called mixed. Whole number part, fraction part. It's like blueberry lemonade. I like blueberry lemonade. It's a mixture. It's got blueberry flavor and it's got lemonade, right? You mix them. Mixed number, whole number, fraction. So how many 5s can fit into 48? 9. Because I know my multiplication factor. I know 9 times 5 is 45. So this is going to be 9. That's my whole number. But how many is left over after you do 9 times 5 and get up to 45? The difference between 48 and 45 is 3. Difference means subtract. You get a difference after you subtract two numbers. 48 minus 45 is 3. So 3 is going to be your numerator. And then you keep the same denominator, which is 5, because in terms of groups of 5, like how many groups of 5 fit into 48? 9 whole groups of 5 can fit into 48, but then 3/5 of a group of 5 also fits into 48, right? So you got 9 whole groups, then you got 3/5 of a group. So 9 and 3/5 can fit into 48. Now, it's also important to understand fraction and decimal equivalence. And you will know that 3/5 is equivalent to 0.6. 3/5 is the same thing as 0.6. Check this out. If you had a dollar, right, and you broke a dollar down into 5 equal parts, because your denominator is how many equal parts you got. So break a dollar down into 5 equal parts. Each part would be 20 cents, right? Because 20 cents times 5 is a whole dollar, right? So, but if you had 3 of them, if you had 20 cents 3 times, that's 60 cents. 60 cents is 0.60. 0.60 is the same thing as 0.6. So this is how you know that the answer is right. Either way, you get 9.6. You know what I'm saying? That's what I like about math because it's so versatile and flexible. You know what I'm saying? Right? So, just a little something on how to multiply whole numbers by decimals. All right? Now go get some practice. Stay locked in. Tell people about the channel. See you all in the next video.